All right, folks, here we are with the Unit 4 test review. So kind of get our brains all together for all the topic areas that we're going to see in this unit. So I'm going to give us one example, and that's going to kind of carry us through everything that we will see throughout, or that we have seen throughout this unit. So our example, let's go to example 1. You're going skydiving. I'm not, but you are. I don't like heights. Let's say it costs $120 to rent the gear. To rent the gear used to jump. And it costs $80 per jump. I have no idea. I made up all this information. Okay, so I can take this information though, and I can put it into function form. So we can say f of x or y, doesn't matter, those are saying the same thing, equals, well, $120 rent the gear and $80 per jump, so let's go 120 for the gear plus $80 per jump, x representing the number of jumps. We can take this information, we can put it into an input-output table or an XY table. It doesn't matter. All of those things are synonymous for one another. Let's go 0, 1, 2, 3 jumps. If I plug in 0 for x, I get 120. So I just run this off on an even jump. I got scared. But they're going to charge me because I wasted their day. 1 jump, $200. 3 jumps, sorry, 2 jumps, 280, 3 jumps, 360, so on and so forth. All right, so I can take this information and I can put it into what we call a relation, where it's just our ordered pairs that we could graph. So 0, 120, 1, 200, 2, 280, and 3, 360. Okay, that's our relation. Then we can list our domain, which would be our input or our x's, 0, 1, 2, 3. And then we can list our range, which would be our outputs or our y's, 120, 200, 280, and 360. All right, so I can take all this information and let's graph it. Put it into an actual graph here. All right, it doesn't have to be perfect. It's no big deal. All right, so we'll label the bottom as jumps. We'll go by ones. And then let's go to the other side. Let's do that by money. Let's go by hundreds. All right, so we can take our relation and we can place this information in here. So 0 jumps, $120, somewhere around there. 1 jump, 200. 2 jumps, 280. 3 jumps, 360. And we'll just stop for there, okay? This information is linear. It's a straight line on our graph and has a croc. So if I didn't graph this information, I would know it's linear because it has a constant rate of change. It is a function. Because each input has exactly one output. If I were to do a vertical line test, it would only go through one point at a time, so that would also prove it. This information is discrete. Because my domain is representing, my domain or my input is representing jumps. And it's discrete because that's telling me my domain has to be whole numbers, which tells me I cannot have half a jump. They're not going to charge you for half a jump if you make it halfway down and then the plane scoops you back up or something. Since it's discrete, we only have the dots. We do not draw a line. All right, and that's pretty much everything that we need to know from this unit in this problem. And we can apply all of those ideas and those statements for everything all over the place. But like the big things that that are not kind of cut and dry, the linear part, making sure it has a straight line, or it has a constant rate of change, or it has a pattern within our data. Is if it is a function, each input can only have one output. So like, one jump's not going to cost me $200 or $280. It just cost me $200. The discrete or continuous data part. Continuous could mean that the data could be a decimal, but obviously not in this situation. That's why it's discrete. The only other thing that we could do is we could create a qualitative graph based on your actual jump. Okay, so we could create a qualitative graph based on the jump. So let's create a different graph. Let's say time, and let's say our height from the ground. Okay, now I don't really know how it works. I've never really done it, but I'm assuming maybe we're up in the plane, and whoop, we jump out, and we're probably going down at a constant rate. But then it seems like those people kind of like, I don't know. It doesn't seem like they fall the entire time, in my opinion. It seems like it's kind of like they level off and they vary, and it kind of depends on what you're doing, and kind of if you're trying to like put your face down like you're diving into a pool, but you're diving straight to the ground. So sometimes if you do that, it's going to go at a little bit of a faster rate, and then maybe you'll finally eventually pull the string for your parachute, and that will come out, and maybe you stayed at the same rate for a while, and then you pull the string, and then now you're going to go down at a constant rate until you're finally hitting the ground. I don't know. That's kind of how I would describe qualitatively what's going on here. Obviously, you don't jump out of the plane, then go back up, and then come back down and go. I don't think that's how it works. I think you're pretty much consistently falling, or maybe staying at a similar spot depending on if you're doing a trick up there or something. All right, that's all the ideas that we've seen through this unit. So it's all kind of there for us. Let me know if you have any questions.